Broadcast is now starting. All attendees are in listen-only mode.
Good morning and afternoon. Welcome to this live webinar session on fire suppression systems for heavy-duty mobile and industrial vehicles. My name is Kristen Motz and I am part of the marketing team at Johnson Controls. Today's session will be presented by Kristen Reisig, Global Product Manager for Ansell branded vehicle fire suppression systems for Johnson Controls. I'd like to cover a few housekeeping items before I hand over to Kristen. During this session, all attendees will be in listen-only mode. However, we will be more than happy to answer any questions during the presentation. We have a team of panelists in the background that will be able to answer any questions you might have. So please use your question box in the GoToWebinar panel to send us your questions. If time permits, we will answer questions live during the webinar. The session will be recorded. All attendees will receive the presentation slides and recording within a few days of the session. All participants that stay on for the entire 1-hour session will receive a certificate of completion from Johnson Controls. You will also receive a short survey at the end of the webinar to provide feedback. Now, I would like to hand over to Kristen Reisig, and I wish you all a great webinar.
Thanks, Kristen. So thanks for joining us today on the webinar for our vehicle fire suppression systems from Ansell. As Kristen mentioned, my name is Kristen Reisig. I am the Global Product Manager for our Ansell vehicle fire suppression systems. I've been with the company just over 10 years and have roles across portables, clean agent, gaseous systems, and then now most recently joining the vehicle team. And I'm happy to share my knowledge and information with you guys and continue to grow in my market understanding. We have a variety of topics that we're going to cover today. Just general, what is vehicle fire suppression? What is fire? What are the different industries that we see, mobile vehicle fire protection in? How do we determine what to protect? What does a good fire suppression system look like? The codes and standards and approvals that you might look for and see, different suppression and detection options that exist in the market, and then dive deep into our new liquid suppression and what that means for the industry. So to start off, vehicle fire suppression is really the addition or use of fire suppression systems on mobile equipment. The assets and equipment that utilize the fire suppression are selected by understanding the risk of fire across the different fire classifications and the severity if a fire were to occur. The severity can be to the equipment, to the personnel, to the environment, or even the business productivity. Fires on mobile equipment can be caused by defective components, ruptured hoses, bad or worn out connections, buildup on filters, but they can also be due to the installation of hardware with incorrect fittings or improperly torqued connections. Additional ways that fire can start is the buildup of static or other environmental conditions, or as a result of typical operating conditions that might exist around the equipment. With some of those reasons for fire, let's take a look at how fire exists or really comes to be. Fire or flame is the visible effect of the process of combustion, which is really a special type of chemical or chain reaction. Combustion occurs when there's a reaction between heat, oxygen, and fuel. Depending on the amount of available oxygen, combustion can be either slow or fast. When it results in a flame, we typically call it burning. There can be the start of slow combustion long before the human eye can see fire or flame. An example of this would be a smoldering electrical component. There's a chemical or chain reaction happening between heat, oxygen, and the fuel that is slowly combusting, even though we may only be able to smell it, but can't see visible flame or even smoke. Smoke is often visible during combustion before flame. You can see on the slide some examples of each of the elements of the fire tetrahedron that we would see on mobile equipment. Examples of heat are superheated turbochargers. Oxygen might be air passing through a compartment, and we have a variety of different Class A and B fuels on a lot of our equipment today. The fire triangle is really what drives, or fire tetrahedron as it's often referred to also, is really required to sustain a fire, and those three elements are essential. You can remove any one of those main elements to suppress fire, as all of them are required to maintain combustion. We'll talk a little bit later about how the different types of suppression systems interact with the different processes. Heat is there because the fuel must be heated to its auto-ignition temperature. As I mentioned, fuels can be solids, liquids, or gases. And the oxygen is needed for the reaction to occur between the fuel and in the air. And then when you see the chemical reaction, as an example of that occurs, right, when we have a Class B fuel and it's heated to the point where it releases gases from the surface, and then the gases react in combustion. Those hot gases break apart into fragments, which then combine with the oxygen from the air to form new product molecules, such as water and carbon dioxide. The heat that's generated by that reaction then also sustains the fire. Heat and fuel are two very important considerations in understanding vehicle fire suppression across the industries that we protect. Here are some key industries that we should pay special attention to that have hazards that exist, and we've already been protecting assets within these industries, but this list isn't all inclusive. Ultimately, any industry that has mobile equipment and possesses the risk of fire, as we just discussed, would be able to be considered for fire protection as an added insurance, we'll call it, for occupant safety, asset protection, and business continuity. Thinking about all these things, one might have trouble deciding what vehicles or mobile equipment should or shouldn't be protected. And the joys of live webinars, that sometimes the slides don't advance. Give me 1 second here.
We apologize for the technical difficulty. Kristen, let me know if we need to switch over to Navi to present for you.
Yeah, that might be. I'm getting the spinning circle of blue death, so that would be appreciated.
Navi, I've made you a presenter. You should be able to present the slides. We apologize for the technical difficulty. Are you there, Navi? I'm sorry.
I am. Are you able to see the screen?
Now we are. And now you need to just change your display settings up top. Oh, we lost you. Oh, there you go. Perfect.
And then we can go to the next slide. Okay, so as we discussed, deciding what to protect and what not to protect is really determined through a fire risk assessment, or otherwise known as an FRA or hazard analysis, and is the key first step to understand what or if a piece of equipment would benefit from fire detection and suppression system. The FRA is there to review the general vehicle layout, the occupant's interaction with the vehicle, where ignition sources exist, what the potential sources of fuel are, how fire can propagate throughout the equipment, how big a potential fire could be, which is often dictated by the available source of fuel, and the ability for an operator to safely egress. Each of these are then reviewed for the likelihood to occur and if they were to occur, how severe the impacts of a fire would be. The combination of all these activities then gets reviewed and assigned a scoring or rating that helps tell where the suppression should be installed on the equipment. If the blue flow chart, within the blue flow chart are some prompting questions that you could ask yourself as you think through each of the activities I just mentioned. This is something that our applications engineering team is able to support if you were to have questions about a specific piece of equipment or machine and might need help or support with a FRA review. You can do that by contacting us at avst@jci.com. Next slide. As we finish up talking about how and where we would look for risks of fire, just wanted to highlight that, unfortunately, proof is in the pudding, and the risks are real, and fire definitely exists and has occurred across multiple different industries, and that the potential for all different types of vehicles and mobile equipment to catch fire for the variety of reasons that we discussed is there. Oftentimes, the assets that we see vehicle fire suppression installed on are a significant investment for a business, and the suppression system is there to minimize the impact or the potential of significant damage to those assets, but also for the safety of the vehicle operator, the effects on the environment, and the overall business operations. Just as we discussed, right, the different risk analysis and the impacts and the needs for fire suppression, these 5 things are really the critical elements of a good fire suppression system. First is that the fire risk analysis that we talked about, understanding the true risk and the areas that need to be protected on equipment. Then, after understanding the fire risk analysis, we can generate a system design. The system design being adequately completed and in accordance with the FRA develops the design intent and and the asset protection that's best suited. In the system design, things that we need to consider are nozzle placement and how it's aimed, how much agent do we really need, how we're going to detect and actuate the fire suppression system, and then also, right, how are we going to notify a vehicle operator if that fire were to occur, or if there were faults or issues with the system. And then, you can have a design as best as you can, but that next step comes down to how that equipment is installed, making sure, right, that all of the OEM requirements are followed, that the design intent is met, the use of a certified installer that is aware of the equipment, the design, and the functionality of the system, that all of the authorized components are used, and that you're able to test the installation after it's complete in order to ensure functionality. But the system doesn't stop there. The maintenance and ongoing upkeep of the system is just as important. And making sure that it's done in accordance with the requirements as you would see in an OEM installation and service manual, and you're following the required semi-annual and annual maintenance, and any attention to alerts or notifications that an operator might gain from the system. And also, finally, the record keeping. Knowing what products and how the maintenance were done on the equipment, and by who, and with what, are important to understanding the longevity of the system. Building off of that, there are industry standard codes and approvals that you can look for across the industry that will help to ensure that the fire suppression system meets all of those criteria. Some of those that you might look for are FM 5970, AS 5062, the NFPA standards 120, 122, 17, and 17A, MSHA certification, and CE markings. All of these bodies have additional standards and requirements that OEMs or vehicle suppression manufacturers are required to meet in order to produce the fire suppression systems. In this next section, we're going to take a look at the different types of suppression and detection that exist in the market today. Under suppression agents, we see a variety of different options that exist. These are dry chemical powder, liquid agents, twin agent systems, which are oftentimes the combination of dry chemical and liquid. You might see gaseous systems, and also in some regions, mobile equipment is heavily protected with foam. Following on the suppression system would be the detection. There's a variety of methods of detection that we see in the vehicle space. These are linear detection wire, different methods of heat detection. Sometimes it's loss of pressure, spot thermals, and also IR detection. When you look across those different types of suppression options, if you focus in on liquid suppression, that liquid suppression system suppresses fire primarily through cooling and chemical reaction interruption. So like we talked in the fire tetrahedron, the liquid system is there to remove heat by doing the cooling and also that chemical reaction interruption. Liquid suppressions are most well suited when they have both the cooling and suppression capabilities. It's important in liquid suppression systems today to look for a non-fluorinated liquid agent. How does that system or the agent affect sustainability ratings, the ability for the system to meet flame knockdown, have multiple different tank sizes that you can optimize, the agent quantity that would be needed on the equipment, have third-party listings, wide nozzle coverage areas, and being able to get nozzles in tight spaces, so maybe even as close to 6 inches. Another key important thing to look for in liquid suppression systems is getting down into the freeze protection range in the temperature rating. On dry chemical systems, these systems suppress fire by interrupting the chemical reaction. Dry chemical systems, it's important to look for suppression capabilities, having multiple tank sizes to be able to have the right amount of dry chemical to suppress fire risks. Similar to liquid, right? Looking for those third-party listings. There are oftentimes in environments and rating temperature requirements that would need to get down to -65, or in tight spaces, right? Like you might see in some underground mining where there's low profile options to be able to get those tanks in tight spaces. And another option, right, is the nitrogen or gaseous systems. And these type of systems suppress fire by removing or displacing oxygen. Similar to like what we talked about on the liquid system, right? Nitrogen removes oxygen from the formula that we saw at the beginning. By removing one of those 4 elements, we're able to suppress fire. Nitrogen is used specifically for suppression. It's important to, when you're looking at a gaseous system, right, to look for an atmospheric gas that meets sustainability requirements. Even with, gaseous systems, there can be multiple tank sizes to vary the amount of agent that's delivered. You want to be able to minimize any venting requirements. So with gaseous systems, we displace oxygen by putting more volume of gas into an enclosure. So being able to vent and not overpressurize an enclosure is important. Looking for something that's tested in accordance with industry requirements, and then like across all the other ones, right, that wide temperature rating. As we know, sometimes mobile equipment gets moved all over the world. And then, we could have suppression without detection, but the benchmark of that complete solution is by tying the suppression in with the detection or actuation. Go to the next slide. So the detection and actuation system on a vehicle can vary drastically in the options and capabilities that exist in the market. The simplest of systems would be, right, a manual actuation system. In this system type, you're relying and a bystander to see a fire on board the vehicle and physically manually actuate the system. It's often done through a single push button or palm button. It's frequently used in low-risk applications, but it does require an operator to approach or get closer to an on-fire vehicle to operate the system. If selecting a manual actuation system, look for one that can actuate multiple tanks from that single operation and that has an operating temperature range adequate for the hazard area. And also one that can operate notification devices such as a horn or strobe, as well as the compatibility to initiate shutdown devices. Then when we move into the automatic detection and actuation, the type of detection can vary greatly in these systems, from linear wire, spot thermal detectors, the variety of IR detectors that are on the market, as well as other means of thermal detection. Ultimately, you need a type of detector that is best suited based off the FRA conducted in order to quickly detect the fire or heat for the system to actuate for the suppression system to work. The automatic detection and actuation system is designed and selected based on the ability for the system to operate without physical intervention, but having the ability for the user or operator to be able to fire the system is also valuable. Having the detection signal latch and register in the controller is also an important feature to look out for, as is the monitoring of the different circuits that exist. This gives us the monitoring capabilities that the operator knows if there's an error or fault within the system, and the messaging is best provided with an easy to understand visual indication on a user display. In addition to the visual and audible indication to the operator, having the ability to access a history log within the system also provides valuable information about the system and the events that happen. In this case, that history log is basically the picture that can tell you 1,000 words. System is critical. Automatic detection is critical in order for us to, kind of provide that holistic solution that doesn't require manual intervention by a human, right? So that, whether we're there or not, that fire suppression system is going to operate. As we look forward, we talked a lot about the different types of suppression and detection, but one key advancement that we've taken a look at as a company is what about liquid-only suppression, right? There's a lot of standards out there today that require a twin agent system, dry chem, or liquid as an additive. And some of the history here, right? Dry chemical systems have been an industry standard or go-to solution for fire protection since the mid-20th century, which was then expanded in the 90s to complement the dry chemical system with liquid, which is what you would see as the typical twin agent system. The concept here was that dry chem would give rapid flame knockdown, and the liquid would provide the cooling capabilities to minimize the reflash that we talked about when you have superheated surfaces that are running above the auto ignition temperature of the different fuel sources. The surfaces can exceed the temperature of auto ignition, and then the contact of that fuel source with the superheated surface could cause combustion. The design intent of the liquid and the liquid-only system is still to reduce the surface temperature of the surfaces so that they are below the auto ignition temperature of the fuel. In 2011, the ANSEL LVS system was released as a standalone suppression system, providing both cooling and suppression capabilities. Even with the FMM approval of the system, like I mentioned, there's still standards that require the use of or recommend the use of twin agent suppression systems for equipment, right, such as we would see in NFPA 120 or 122. In support of the liquid-only position, as we expanded our liquid suppression product line, we introduced the NF40 LVS and produced a white paper based off of the testing and documentation that we have to support, right, that liquid only is equal or better in performance than what we have seen with our twin agent. In 2022, we introduced the NF40 non-fluorinated liquid suppression agent to meet the protection challenges of the vehicles that we see today. The standalone system delivers extraordinary firefighting performance and exceeds the capabilities of the traditional twin agent system. The claims and data that I'm talking about are supported by the white paper that we published, and this white paper can be used to influence decision makers on why a single agent suppression system can be the best route for suppression and cooling in these different applications. We see increased firefighting performance with NF40 agent, and as we'll see on the next slide, increased firefighting performance with less agent. Like I mentioned, the non-fluorinated suppression agent doesn't contain the intentional addition of per and polyfluorinated alkyl substances or PFAS. The freeze protection down to -40 is really important when you look at the different environments that we see vehicles across the globe. An important characteristic of liquid is the ability for that liquid to flow in the same way that you would see some of the Class B fuels, and limiting any fuel propagation. It's also important to note that NF40 doesn't require any annual replacement of the agent in the system. So on to the testing that we conducted. This table just summarizes some of the various testing that was conducted and is documented in the white paper that I just mentioned. This testing was configured by our engineering team that support the Ansel vehicle systems to understand real-world application and impacts of our fire suppression systems in those applications. The white paper, which we'll provide to all of the attendees during this session, covers the testing in great detail. And you can see in that white paper the different charts that support the cooling and extinguishment times that you see here. All of these tests were completed in efforts to push the industry standard test procedures that you would see from some of those third-party approvals that we talked about a little further to understand the impacts of the liquid agent on superheated surfaces when something like a hydraulic line would rupture, or you have a high pressure spray of fire onto the superheated surfaces. As you can see in this table for LVS NF40 in test number 5, the extinguishment happens in roughly half the amount of time as what you would see with the twin agent, as well as with half the amount of agent required to complete the same activities as the other tests. And to note, some of the agents were effective at gaining extinguishment in these specific test scenarios. Not to say that they're not sufficient or adequate, fire suppression methods, but in this comparison, they were not able to achieve the same successful results that we were able to do with just NF40. It's important to note that this testing was done with high pressure hydraulic fluid, which lowers that high pressure lowers the auto ignition temperature, which requires the agent to really be a best in class for cooling of those superheated surfaces and ensuring that reignition doesn't occur. With that, you can see why we're passionate about liquid suppression capabilities and how we're working to educate installers and users and industry standards that liquid is viable as a standalone suppression solution to be as good, or in this case, as you can see, better performing than the alternatives that have been on the market for the last few decades. And with that, it wraps up the body of the presentation. If we would like to take some questions.
Just to remind you, if you have questions, just drop them in the question box. And Chris and Dan, you can come off of mute and read any questions that we have.
Yes, hello. So the only question we have to date is regarding the measurement between the nozzle and the hazard area, asking if that is the measurement that Kristen referred to, or if it was actually a pipe length or a hose length. So the question is, for the LBS testing, is that agent nozzle distance the distance of the nozzle to the hazard, or the pipe length from the tank to the nozzle? And the answer to that question is it's the distance measured from the tip of the nozzle to the hazard, to the fire hazard.
Thank you. Great question.
We do have another question from Jerry George. And he's asking, what type of nozzle are you using? Chris, if you want to come off mute and answer that question, we can start to read these questions live and answer them live since they're coming in. I see a couple more questions coming in.
So to answer the nozzle question, the standard 9.5 was used in the testing. And there was another question from Don Cooper. Was the distance for the testing, or is that the minimum design distance? There's actually a range of distance that was used. In the NF40 manual, you'll see that we have different ranges of that nozzle based on the testing that we did do. There's another question, Nineth Babu, sorry if I mispronounced your name. The question is how these systems are sized. Is it based on the engine size? No, the systems are actually based on nozzle quantity needed. We determine the nozzle quantity needed by doing the fire risk assessment that Kristen had mentioned earlier in the webinar. We'll go through and look at a machine, break it down into areas and identify the hazards. And then part of that, we also come up with a mitigation scheme to cover those hazards with fire suppression, and that will lead us to a nozzle count. Michael Carlson, the question, are you going to do a presentation on the new user build check fire wire? So we do have some how-to videos out there. I do believe, Kristen, can you correct me, but I think those are on our LMS portal. Would that be correct?
Yep, there are some training overview, like summaries on the new the Checkfire D product line. Nabby, if you want to advance 1, 2, 3, 4, 5 slides, I can touch on that product that he's talking about really quickly. We have some of the information in the appendix slide. Yeah, so thanks for the question. As mentioned, right, we recently introduced our new Checkfire D products for our Checkfire 110 and 210. And this is really a new upgrade to the system with an adjustment or advancement in the connectors that we use. So instead of what maybe you had seen previously in the Ansel product line with our circular connectors, we've changed that product design to use Deutsch connectors. So it gives some flexibility to the market and able to follow our requirements and installation needs so that we ensure the IP rating, but be able to make the field lengths and field wireable connections that that maybe others are used to. Really important, that these connections meet vibration and durability requirements of whether it's the standards we talked about or other vehicle OEMs that are in the field. One neat piece of information about this product line is it's reverse compatible for service of the legacy or existing Checkfire systems that are in the market, where we can remove the circular connector and add the DT connector without needing to do a complete system install. And it gave us some improved mounting capabilities for our cables, and really improved the requirements for components on hand for service and installation. So great question, thank you.
And Dan and Chris, I see a couple more questions coming in. I'll read Lee Robotis' question. Is there an estimated cost per system or cabin area?
Dan, would you like to take that one?
And so as far as pricing goes, obviously it's dependent on the vehicle size. So since you're looking in this vehicle space from vehicles all the way from a fork truck up to a multi-million-dollar mining shovel, the costs on it can vary from, if you go without detection, from perhaps as little as $1,500 all the way up into the $35,000 range. Or if you start getting onto a shovel and you're looking at multi-systems, so you might have clean agent, liquid system, and perhaps a dry system all on the same shovel, you could even exceed that number. So it's really a function of doing that fire risk assessment and then figuring out exactly what that system size looks like and then price it accordingly.
You're welcome, Lee. And we have another question from James Kennedy. Can this system be retrofitted? Can any parts be reused with Checkfire 110?
Yep, so as I mentioned with the new release of the Checkfire D product, that reverse compatibility for service of legacy systems does exist. So right, if you've got an existing 110 system, you would just need to, as part of the service, if you need to update a cable, you can use the new Checkfire D cable, and you would just need like a connector kit to be able to replace the existing circular connector with a DT connector to be able to connect into a new cable.
Awesome. Thank you for the question, James. We have another question. What kind of, the questions are coming and moving them up. I apologize. What kind of fire protection on the electric battery equipment? Any new equipment? Anything new? So for electric battery equipment?
Yeah, I can take that one. So there's a number of conversations that are happening in the marketplace around lithium battery and electrification of vehicles. JCI, other fire companies, insurance companies, the approval agencies across the industry are continuing and have conducted extensive battery fire testing. Some of the things that we've learned is that there's so many variabilities in the battery chemistry, sizing, spacing, configurations, makes it really difficult to provide a one-size solution. We know that there's not a way to stop thermal runaway should it happen. And really most of the guidance that exists in the market and what we're seeing is around containment should a fire occur. We have initial plans to partner with a vehicle OEM. We're continuing to engage with several companies in order to evaluate options in development and partnership to make sure, right, that the solution meets the application. But what we've definitely seen, right, is that conversion from diesel to EV has been slow, but we continue to track and work to find and partner with a solution.
Great. Since we have time, we'll just keep going with the questions. How do we know when to use a specific type of vehicle system, for example, dry?
You can take that one. We recommend anything with a superheated surface or a high temperature surface that LVS be used. Other applications can use dry chemical, but we strongly suggest using the wet LVS on almost all applications.
Okay, thank you. Is there a standard Ansel sizing depending on the size of the motor or model of equipment to be protected?
Standard size is based on the hazards identified, like we had mentioned earlier in the fire risk assessment. There isn't a standard out there at this time.
Okay. What is the estimated lead time on components for these systems?
So I guess I'll take that question. So throughout the COVID years, we had supply chain issues, much like many manufacturers, not just in fire suppression, but across the globe. And as part of our recovery from that experience, where we did have longer than anticipated, longer than desired lead times, we went through product developments to try and get in a position where we had multiple suppliers for our equipment. And that process was part of the development of this 210D product that we introduced. So we've gotten away from some of our sole sourced product lines and currently have a much better, not quite immediate, but almost immediate supply on all of our products in the vehicle space. So if you're asking that question specifically related to the problems that we've had in the past, I think we've recovered from that experience and can get the product out in a matter of a week, maybe two at the most.
Absolutely. Thanks, Dan.
Thank you, Dan. How often does vehicle system require maintenance?
Systems are required semi-annual or sooner based on the environment that it's used in. The harsher environments, we recommend more maintenance to be performed to make sure everything's in the correct working order.
Great. Thank you. And thank you for all these great questions. And again, we have time, so we're going to keep going with the questions. Coming back to EV model equipment, would you recommend, I guess he's asking, what would you recommend for EV model equipment? Any thoughts?
Kristen, do you have any thoughts on that?
And if we
Yeah,
can't answer on this call, we can follow up with.
Like I mentioned, right, the variability in each of the battery chemistry, sizing, spacing, and configurations is really the challenge in being able to give, I'll say a one size fits all option to really be able to answer that question for you, unfortunately.
Okay, next question. Talk about when to choose N101 suppression. What are the parameters?
Good question. So the N101 was designed for electrical enclosures. A few of the parameters are the unenclosable openings and the overall size of the unit. So those are some of the biggest key factors when we're looking at the N101 system.
Yeah, and I'd say one of the big differences when you look at the N101 or gaseous suppression over liquid or dry chem, right, is that naturally occurring atmospheric gas upon discharge is going to displace oxygen and provide suppression, but it's going to maintain, for lack of a better word, the cleanliness within an electrical cabinet, right? So when those connections and that equipment requires some level of cleanliness to be able to make sure that, those electronics are operating in the intended way. The nitrogen gas isn't going to interact with the electronic components. It's not going to, leave a residue on them. It's not going to conduct electricity. And those things are really important for making the decision on maybe where N101 would be best used.
Great. Another question is, LVS approved to be used on aircraft service equipment?
At this time, yes, the LVS is approved to be used on aircraft service equipment or ground support equipment.
Okay. I'm going to, the questions are still coming in. Thank you for your questions. Why did the LT-A-101-30 cartridge bracket change recently? Now, if that's too detailed and requires a follow-up, we can follow up.
Do you want to take that one, Kristen?
Sure, I can. Yep. So the cartridge or the bracket change for the LTA 101-30 cartridge. For those, I guess, that aren't familiar with it, the main body of the bracket has always held the cartridge with a strap around it, and then on the top of the bracket there was a metal hoop that would go around the actuator that would be installed on top of the cartridge. And maybe in some pictures you're used to seeing the Ansel cut out in that hoop. Late last year, as part of our initiatives to become more sustainable, as well as be able to meet product delivery expectations from our customers, that hoop was removed from the bracket, as it didn't impact or affect the performance of the bracket. So we were able to reduce weight, by removing that additional metal hoop that was on top of the bracket, but still be able to maintain all the requirements that we needed to for securing the cartridge and ensuring it meets vibration requirements and performance.
Thank you for that answer, Kristen. I'm going to read Rudolph's question, but Chris and Dan, can you read Troy's second question and let me know if that can be answered on this call or it requires follow-up? It's very detailed. So I'll read Rudolph's question. Does Johnson Controls provide training on system design?
So we have a, I'd say pretty detailed training platform methodology that we use for our authorized distribution and installation partners that are, our go-to in the field for doing design, installation, and service of our equipment. There are times throughout the year that we might give, like a product awareness training, but that overview training is not the same as what an authorized Ansel distributor would get for design and installation and maintenance. I don't know, Chris or Dan, if there's anything you want to add on that, though.
One key thing to throw in there, Kristen, is we do have a technical service team here. So if there are training or questions of design after the training, the 3-day certification training, we are here to help. We have a team here, and we also have them, throughout the world that are able to assist as well if there's additional things that are questioned. So with that, if we want to go back up to Troy Barnett's question, Troy's question, what's the best approach for navigating nozzle placement on some of the newer machines that have Tier 4 systems and little to no room for mounting and placement locations? Has this been an issue with others trying to get adequate protection in such tight limited spaces? So one good thing, Troy, I'm not sure if you're aware, but we have about 2.5 years ago, we did launch a new nozzle, which was what's called the 9.5W nozzle. So it is a wide angle nozzle that is good from 6 to 18 inches. And at 18 inches, it has approximately 50-inch spray pattern. So when you're getting into those very limited tight areas, that nozzle is available. One of the main design guidance that we do have on that nozzle is it does need to be a minimum of 6 inches away from any superheated surface, so we don't have any issues with the nozzle cap.
And the only other thing I would add to that one, right, is we also have an adjustable swivel adapter that I'll say somewhat recently released in the last few years, that might make positioning and aiming nozzles maybe a little bit easier than what you would see with just the traditional like hole mounting pattern that's available on like our nozzle brackets. So if you haven't seen that, definitely check that out.
Great, thank you for all your really great questions. We have another question. How is the uptake of vehicle suppression systems in the market? Have you segmented the market to maybe mining, light vehicles, etc.? This will be very important so that we can better understand our main target market. And that's from Benson. Thank you, Benson.
Yeah, I would say, right, we on a regular, ongoing, continued effort review the different market verticals that we see as fit for purpose for our suppression products. Whether it's mining vehicles, if it's aviation, waste processing, ports and harbors, transportation, all of those different verticals, have a different market footprint. We play very heavily in the mining vertical. There's other products on the market that maybe are primarily seen in the transportation vertical. But all of them really have a good basis for, a need for suppression and the opportunity to do so.
Wonderful. That is all of our questions. Thank you so much to our attendees for asking so many great questions. Just as a reminder, this call has been recorded. In the next few days, you will receive the slide presentation in PDF and the recording, along with any additional supportive materials. So we just ask that you fill out this survey and share your feedback, suggestions on new topics. But at this time, I'm going to say thank you to Kristen, Chris, and Dan for your time answering all of these questions. And I wish you all a wonderful rest of your day. Thank you for joining this session.
Thanks, everyone.